Alright, so we are solving this example. So a ball of mass 0.1 kilogram is thrown vertically upwards with a speed of 10 meters per second from the top of a tower 10 meters high. Full stop. Neglecting air resistance, its total energy just before hitting the ground is, and we're given this value for acceleration to the gravity g. Okay, so let's visualize it. So this is a top tower and this is the top of a tower. A ball is thrown. Now the ball is thrown with an initial velocity of 10 meters per second from the question, from the top of a tower. Okay, so we have to find the total energy just before hitting the ground. So the total energy at this point, it goes to the highest maximum height and then starts descending. So it's descend. So we are asked for this total energy just before hitting the ground. So what's total energy at this point? Okay, you must understand that there's a law of conservation of energy. The law of conservation of energy says that energy can neither be created nor destroyed, but can only be changed from one form or transformed from one form to another. So at this maximum height, there's a momentary stop. The velocity is 0 at this maximum height for the object. This is there's a momentary stop, okay, before it starts to descend. So the reason is that gravity is pulling all objects, slowing all objects that are moving against it. So the ball is going up and moving against gravity, which is pulling down. So the ball keeps slowing down till it gets to this maximum height and stops v0, then before it begins to descend. So at this maximum height, its potential energy at maximum height, where v is equals 0, okay, equals its kinetic energy just before hitting the ground. So you can imagine that it starts accelerating when it's coming down. It starts accelerating because gravity is now moving in line with gravity, and gravity is accelerating. At this point, to have its maximum speed, okay? So maximum speed at this point. So maximum speed, remember, kinetic energy is half mv squared. So we can say, because of the law of conservation of energy, the maximum height, maximum potential energy at this point should be equal to the maximum kinetic energy at this point. Alright, so once we get, if you can get the potential energy at this point, it invariably gives us the total energy just before hitting the ground at this point, total energy at this point, okay? So let's do that. We have to obtain maximum height, h, equals to height of tower plus h. So we need to get the maximum height to height of tower plus h. So this h, using the third equation of motion, which is v squared equals to u squared minus 2as. Now the a has turned to minus g because gravity is now our acceleration and it's acting downwards. H, our s can be represented as h. So we need to get the height total. We need to get the maximum height. This maximum height, from here to here is 10 meters. From here to here is 10 meters. We need to get the remaining height so that we can apply it to mgh. Remember, potential energy is mass times mgh. Potential energy is mgh. So please know those formulas. If you've forgotten them, we have potential energy is mgh, and kinetic energy, which is due to a moving body, is half mv squared. Okay, all right. So we have, to slot that in, we are given the acceleration to gravity as 10, initial velocity as 10 from the question, and this is the velocity at maximum height. It slows. Remember, we said it slows down. It stops momentarily, 0. Okay, so make this the subject of the formula. So we have 10 squared comes here, becomes minus 100, and then we have minus 20h. So the height is equal to 5 meters. What height am I talking about? I'm talking about this place. Okay, so from here, initial velocity is 10, final velocity is 0 at this point. Okay, so we can get our h, then we add it to 10 to get the total height, which we will use in our mgh. Okay, so we have height is equal to 5 meters. Alright, so maximum height h is equals to height of tower plus h. Height of tower is 10 meters. We just calculated the remaining height as 5 meters. So 15 meters is the maximum height. So the potential energy at maximum height of 15 meters is equal to the kinetic energy just before hitting the ground. Okay, so mgh is mass of the object 0.1 times acceleration due to gravity 10 times the total height 15. All of this gives us 15 joules. So we're saying that, let's get it again, a ball of mass 0.1 kilogram is thrown vertically upwards with a speed of 10 meters per second from the top of a tower. Top of tower, the speed of 10 meters per second. Okay, from the top of a tower 10 meters high. Neglecting air resistance is total energy just before hitting the ground. So what is the energy at this point? Energy at this point is entirely kinetic energy. Energy at this point is entirely potential energy, because potential energy is due to an object at rest at a height. The object is at a height and is at rest. Of course, at rest because it's not moving. Okay, V is 0. So if you get this place or you get this place, you get your answer. So we've calculated total height as height of tower plus 5. So 15, slot that. So this is our final answer, 15 joule. Alright, so I think that brings us to the end of that section. Okay, we could continue. We could say another example. Okay, because it's always good to have as many examples as possible. An electric water pump. An electric water pump is rated 1.5 kilowatts. Lifts 200 kilogram of water through a vertical height of 6 meters in 10 seconds. What is the efficiency of the pump? An electric water pump rated 1.5 kilowatts lifts 200 kilogram of water through a vertical height of 6 meters in 10 seconds. What is the efficiency of the pump? Okay, so let's state what you are given the question. Power input is or rating. Like I said, the rating, the power rating of a device, of a machine, okay, is usually the power input. This is the power that needs to be put in to the device for it to work. Okay, but take note, not all of that power will be used. Some of the power will be lost due to friction and other issues. Okay, so it's usually different from the power output. So the power output is given from mgh. That is what does the machine actually do. It is rated as this, but it lifts 200 kilogram of water through a vertical height of this. So you can always get your power output from mgh over time. mgh over time. So remember, power is work done over time or energy expended over time. Alright, so we have our mass of water, 200 kilogram, times acceleration to gravity. It's not given, so it's assumed. We have to assume it. It's not given. 10 times height, the height through which the water moves. Okay, so this is work done all over time. All of that takes place in 10 seconds. 10. So unit of power is watts. So this is our power output. Okay, the useful work per time. Okay, now the efficiency, remember again, is power output over power input, or it could also be we'll also look at the other formula for efficiency. Okay, but for this question, this formula works. So our power output is 1002 all over power input. Power input is the rating again. Let the units agree, watts, and then times 100 over 1. So efficiency expressed as a percentage is 80%. Okay, so I wanted to talk about the other formula we need to know for efficiency. Efficiency can also be given by work done by a machine all over work done on the machine. Okay, efficiency is also work output over work input, and work from machines is work output is load times distance moved by the load. The work input is given by the effort times distance moved by the effort. Okay, all right. So, or it's also given by efficiency can also be expressed as work done by the load all over work done by the effort. Okay, or work done on the load over work done by the effort. All right, so take note of this formulae. Okay, all right. Okay, so lastly, let's look at this example. An object of mass 10 grams projected vertically upwards from the ground level has a velocity of 20 meters per second at a height of 10 meters. Calculate its initial kinetic energy at the ground level. Acceleration to gravity is 10 meters per second squared, and we're neglecting air resistance. The question again, an object of mass 10 grams projected vertically upwards from the ground level has a velocity of 20 meters per second at a height of 10 meters. Calculate its initial kinetic energy at the ground level. So I have drawn something like that. So from the ground level, the object is projected. This is a mass object of mass 10 grams projected upwards. Okay, it has a velocity of 20 meters per second. 20 meters per second at a certain height. So this is the journey. This is the object movement of the object. Okay, so at a certain height, at this point, is it has a velocity of 20 meters per second. Okay, so we don't know what the initial velocity is. So I'm using u naught, putting a question mark. But at this, by the time it has covered the height of 10 meters, is velocity is given as 20 meters per second. But of course, we know that once you get to the maximum height, just like in the previous question, the velocity will be 0. At this maximum height has maximum potential energy. Okay, of course, you have to understand that if V is 0, then the expression for kinetic energy, which is half mv squared, is 0, because V in half mv squared will turn it to V0, turn at kinetic energy to 0. So we have maximum potential energy at maximum height of the object, okay, and V0 at that point. So we are told to find, what are we looking for? Calculate its initial kinetic energy at the ground level. Of course, it has initial kinetic energy because it has a initial velocity. This is the highest velocity, and the velocity is slowing down because anything that is moving against gravity is always acting downwards. Gravity is acting downwards and slowing down. It slows down objects that are moving against it. That's why it is 20 meters per second at this point and 0 at this point, because gravity is slowing it down. So let's get the maximum height. Similar. So what are we giving? Mass is 10 grams of object. We convert to SI unit kilogram. Velocity at the height 10 meters. U1 is given as 20 meters per second. Take note, this is not initial velocity. We don't know the initial velocity. Velocity at maximum height, V is equal to 0 from the diagram. Maximum height, okay, U1. So we need to get the, we can get the height. You can get the height using just these two positions, U1 and V. You can get this height, H. Since we know 10 meters, the first height is 10 meters. We can get this other height that will give us the entire maximum height. So let's get this smaller portion of the total height, H. So the H, the smaller part, to obtain height H, you can use the third equation of motion, modify it. Our acceleration, the A is now acceleration due to gravity, and it has to be minus because the object is moving in the opposite direction to it. Our S, which is for distance, replaced with H. So I'm just calculating for this section of the journey of the object. So we have A equals to minus G minus 10. So slot that in. At maximum height, this is 0. Velocity is 0. Initial velocity is 20 minus, put that in 2 times 10. G is given or assumed from the question. Make H a substitute formula. Slot it in. You get that height is 20 meters. So only this portion here is 20 meters. Then that means the total height will be 20 plus 10. So that's the maximum height. All right, so we have that. So there are two ways we could solve it. Say we could use the law of conservation of energy. We state that initial kinetic energy at ground level, initial kinetic energy at this ground level, will be equals to the potential energy at maximum height. It should be equals to the potential energy at maximum height. Okay, because law of conservation of energy is being transformed from kinetic energy to potential energy, but it's neither increasing nor decreasing. Energy is neither lost nor gained, but only transforms from one form to another. All right, potential energy. By the way, let's recap. What are we looking for? Ask for the initial kinetic energy at the ground level. Calculate its initial kinetic energy at the ground level. So at this ground level, what's initial kinetic? It must be equals to potential energy at the maximum height. So we can use potential energy at the maximum height, okay, as equal. So that's mgh. This is the formula. Take note, the formula for potential energy, not kinetic energy, but we're using it because of law of conservation of energy. So 0.1 times 10 times total height 30. So it gives us 3 joules. Okay. Another approach is to actually calculate the velocity here, so that we can slot it into the formula for kinetic energy. This is the actual formula for kinetic energy, half mv squared. So we need to get this v, but to obtain v, we need to get the height. We need to get the v using the total height. Yeah. We need to get it using the total height, not just the part of the height. All right. So we have final velocity is 0. Initial velocity is what we are looking for. That's the velocity with which the object is projected from the ground level, because this is the point of maximum kinetic energy. We need to get the velocity that slots into the equation for kinetic energy. This is v, we need to find it. So using the third equation of motion and using the total height, in this case 30, which is height of 10 plus h. Okay, so u squared is going to give us 600. U is equals to going to give us root 600. I would hence kinetic energy at ground level is equals to half mv squared. So this is going to be this u squared is going to be v squared. Okay, so we've calculated the velocity, the starting velocity, okay, from the ground level. So put that in. You have half the mass of the object times the square of its velocity at this ground level. So u is actually root 600 now, because it needs to be root 600. Okay, so u is root 600. That's what we just got now. Okay. All right. So slot that in. You get the same 3 joules. So the kinetic energy at ground level is 3 joules. Okay. This is actually the potential energy at maximum, but it also equals to K. Okay. So maybe I should just correct it. Let's make it Ke max is equals to, let's make it P potential energy, so that you don't get confused thinking that this is the formula for kinetic energy. Okay. So just say therefore kinetic energy at the ground level, which is it is maximum at ground level, is equals to 3 joules. Why? Because of the law of conservation of energy, which says initial kinetic energy at ground level is equals to potential energy at maximum height. This is just this expression is just it is based on the law of conservation of energy. All right, so that brings us to the end of this session. Thank you very much.